Hello, my name is Abhinav Ojha, and this is Lab-2. The first thing for this lab we did was build a 2-1 multiplexer. So what it basically does is you have input A, bit B input, and then a cell. And then if cell is 0, no matter what you do to B, A will always output, the output will always be A. If cell is 1, no matter what you do to A, the output will always be B, as you can see here, and as you can see here. Pretty self-explanatory. And then we had the second part of the task was to make use the 2-bit multiplexers to make a 4-bit multiplexer. So here we have two inputs, 4-bit, and each of their bits are then used into a 2-bit multiplexer with the cell that we are given, and that just gives you the output of the 4-bit. So if we did 3 here, output is 3, but if I do cell on, output is 0 because cell is on. And then let me show you the waveform. So here's the waveform, and here what I did was I had A and B be the same value for two instances. So as you can see, same. This one just flipped it so I could get the answers to be the same. And I changed the cells 0 and 1. So in the first test, we did input 2 for A, input 1 for B. Cell is 0, so the output should be 2, which is the cell is 0, so that's right. Then when cell is 1, the output's 1. And then for the second time, we did input A is F, input B is 2, and then when cell is 0, output is F, and when cell is 1, output's 2, etc., etc. Same thing here, what I just explained. These were all my tests, and as you can see, whenever I change the cell, my output was the corresponding one. This next thing we did was we just made a display for these. So it's the same thing as the 4-bit multiplexer. Now it just has a display. So if I put 3 here, like I did before, as cell 0, the output is 3, as you can clearly see here. When I make cell 1, the output is 0 because B is 0, as you can clearly see here. So they both are the exact same. Then we made the not slash negation here. So it has some input, a 4-bit input, and then let's make this 3 as well. So if there was no inverting or no negation on it, then we would just get the output of 3. If we were to invert it, we would get the opposite of the bits, so we would get 1 1 0 0 in this case. It just uses XORs to invert it because XORs you can if they're 1 1 or 0 0 will always output 0. So the best way to invert it is if the bits incoming are 0, then you have an invert which is a 1, then you can just use a XOR to get the 1 output here. And then if we were to do the negation of it, then we would get D because that would be the complement of 3. Next, we built AND slash add circuit here. So this basically did AND as the logical AND. So if I do 5 here and I do 1 here, the output will be 1 because the only bits similar between 5, which is 0, 1, 0, 1, and 1, which is 0, 0, 1, is the first bit, which is 1. So the output would be 1. If I was to do the add function on this instead, then what we would do is we would add A and B. So it would be 5 plus 1, which is 6. Now let's remove the add and then let's do pass. So pass through will basically make sure that only A is in our output. So we just pass A through the whole circuit and just get the output of A, which is 5 in this case. Carry in, if we use that with the adder, it's the only time we can really use it. Then we would get 7 because 5 plus 1 plus 1 would be 7. And then we did the ALU, which is the same thing as the previous circuit and add, except now it has an inverter, which is we made in the not slash negation diagram. So if we have 3 and if we have 5 and 1, the output will be 1 because 5 is 1 0 0 1 0, 1, 0, 1, and 1 is just 0, 0, 0, 1, and the only bits that they share is the first bit, so the output would be 1. If we would do arithmetic here, then it would just make it into an addition instead of doing logical AND, so it would now become 5 plus 1 equals 6. Carry in would just make it 5 plus 1 equals 7. If we would invert the bit, so we would get opposite of 5, so opposite of 0, 1, 0, 1 would be 1, 0, 1, 0, which is 10. And we were to add, in this case, so 5 plus 1, and we did the arithmetic, because we did, and when we did the invert, it becomes the negative. So it would be B plus 1 is C. And if we were to do pass-through with everything else closed, we would just get A, as we did before. So A is 5, so the output would be 5. If we were to do a carry-in with the arithmetic, then we would get the same answer as we did before with 5 plus 1, which would be 7. And if we were to do an invert, it would just be B plus 1, which is C, plus 1 because of the carry-in, which is D. That's it. And then the carry out and overflow work the same way as they normally do, where if this is too much, and you do the arithmetic here, 15 plus 1 is 16. 16 would then give you a carry out of 1, and then because it would be 1, 0, 0, 0, 0, 0, and then the output would be 0 because we only care about the last 4 bits. And here were my test cases that I did. So as you can see them here. In my test cases, I first did 0, 0, 0, 0, 0 for everything, just to make sure nothing would be on and nothing was just turning on for any reason. Then I did simple arithmetic, where I did 1, 2, 1 plus 2 equals 3 with the arithmetic on. And then I did an overflow and a carry out arithmetic with 10. So it would be 10 plus 10, 20. We would get an overflow and carry out with the answer 4. Then I did just a carry out arithmetic with a carry in. So it would be 15 plus 15, 30, 31. Output would be 15 with the carry out. Then I did what's it called? And then I just did the similar bits. So 15 is 1, 1, 1, 1, and logical and 0, 0, 1, 1, which is 2, and that would just give me answer 2 because that's logical and. Then I did it again with a pass-through. So the pass-through would make me give the answer whatever A is, and that's F in this case, 15. Then I did an invert of 3, which was 1, 1, 0, 0, and 2, and they don't have anything in similar because when we do that logical AND, then we get a 0. And then I did an invert of 3 with the inverter on. Invert of 3 and then with the pass-through on here, and that would just give me the opposite of 3, which is 1, 1, 0, 0, which is 12, which is C. So our output should be expected C, and that's what we get. And that's it for the lab 2. Thank you.